Okay, thank you so much for joining. Today, I'd like to present online seminar number 59, Visualizing the Confidence Interval. Before we get started, let me introduce myself. My name is Kan Nishida, CEO at Exploratory. We started Exploratory back in spring 2016 to democratize data science. Prior to starting Exploratory, I used to be a director of product development at Oracle and building various data science related products. Since after that, once we started Exploratory, basically we do the two things. One is building Exploratory as a software tool to make it easier to access data science technology and methods to understand your own data. And another thing we do is, including this seminar, we try to share, our knowledge and the skills so that more people can do the data science. So those are the two things we do. And our vision is anyone should be able to make data-informed decisions. I think that's the only way we think is to make this world better. And then our mission is that we want to democratize data science. I think these are things that we can contribute. Okay, and the data science workflow, when we say the data science, we usually start with the business questions or business problem. And then you want to access the data to answer the questions. But unfortunately, the data usually is not ready for visualizing or analyzing. So you want to do the data wrangling to get that data ready. And then you want to do the visualization or analytics with statistical or machine learning algorithms. And then you go through this process, going back and forth. It's very iterative process, and until you find useful insights. Once you find insights, most of the time you don't work by yourself. You work with other partners and customers and coworkers and so on. So therefore, you want to communicate what you have found from the data. So these 5 pieces we think is important. And Exploratory provides a modern and simple UI to make it easy to do data access, data wrangling, visualization, analytics, and communication. Okay, enough about Exploratory and myself. So let's get started. Exploratory online seminar number 59, Visualizing Confidence Interval in 4 ways. So there are various ways to visualize confidence interval, and I like to go through all different ways of doing things in Exploratory. But before getting started, though, let's get a level at the same level. Everybody on the same level. So what is confidence interval in the first place, and then why you need it, and then after that, I like to go through different options of doing this. Okay. So let's say you want to compare the average sales between US and Japan. Just imagine you have the sales or store or whatever, retail, and then you have the sales data coming in. And then you see, you want to see hey, is US is making more money or Japan is making more money. But here, the key is average sales size, right? So here, looks like the customers in Japan, on average, they spend about $2,000. And the US, on the other hand, spends about $1,700. Okay, and there is a difference of $300. The question is this $300 is significant? Significant is kind of like a statistical term, but in a plain word, it's more like, hey, is this something that we should pay attention to? Or maybe this is some kind of marginal difference. Maybe this can happen occasionally. It's not really the big deal. That's the kind of question that we want to answer. And then it turned out there are many customers in US, but not so much in Japan. Let's make it super simple, five customers in Japan and then 30 customers in US. Okay, and then in that case, let's say there happened to be one more customer just came in Japan, and then he spent only $100 on sales. Okay, and then that means though, now we have 6 customers in Japan, and then when you calculate the average sales size, and that becomes $1,700. Okay. So what this is happening here is that one person can make a significant difference in terms of calculating the average when you have only like, let's say like 5 people. Okay, and at this point, this $1,700 is exact the same as a US. So that, therefore, there is no difference between Japan and US. And then if we thought that $300 difference was significant, like Japanese customers are making spending more money, so therefore we should do some more campaign in Japan. We should focus on that market. But then like the next day, that sort of like a conclusion can be invalid. So you want to be careful before making such decisions, right? So same thing is that can happen in the US as well. And then let's imagine like one customer came in US, and then that person spent only $100 or something like that. But because we have much more customers, many more customers in US, so that particular one person can change the average, but that amount of the change is going to be very small compared to the kind of change that we saw in Japan. That's because there's this one person is just 1 out of 31. So therefore, it doesn't make that much of a difference, right? So what does that tell us, right? So that is when you have the smaller size, in this case, when I say the size, is the kind of data size, the size meaning like a number of customers, then that means that the average numbers coming out from such small size of data is not so reliable. I'm not sure like how much of the confidence we can be with that average numbers compared to the average number coming out from the bigger size of the data. Okay. So I draw in the right-hand side, basically the left-hand side, right-hand side, it's, visualizing the same information. The difference is the left-hand side is the bar, right-hand side is the dot, and the dot is basically kind of using the position to visualize the average sales. Okay, but focus on the right-hand side chart. I'm going to just draw some kind of a vertical line. This basically, like the reason I'm doing this is we want to draw some kind of line or like interval. Then maybe like, Japan, given the 5 customers, the average number happened to be $2,000, but maybe there's some kind of like what do you call it, the variance that the average number can be different. So what could be that range, right? So like some in special expert world is that we call it like error or something like that. But what is that different the interval or the what is it, like the range that we should have within which the true average number can reside? Okay, and I intentionally changed the length of the line between US and Japan because, like I said, Japan, because we have only 5 customers, I'm not that confident. So like maybe like I'm going to make it bigger or wider so that, true average sales can be within this range. Compared to US, we have 30 customers. So I'm more confident on that, average number coming out from that data. So therefore, like, it can be, maybe like it cannot be, 1,700, but should be within this range. That range can be shorter than the Japan. Okay. So what we have just we are doing here is we are estimating the real like average values should be within this range, and that's the basically the confidence interval. Okay, this is a very high level concept or like a abstract thing I'm talking about right now, but just imagine, I want you to understand this is the confidence interval that basically the range or the interval within which the true average value should reside in. That's something that we expect, okay? And then, so what is a true average or mean, right? Mean and average, basically the same thing. So left-hand side, all potential customers. Right-hand side, there are 5, this is actually 6 now, but 6 customers, maybe in Japan or whatever that could be. Okay, so the right-hand side is the current customers or the data we have in our hands. But then it could be, it can be like other 1,000 or 100,000 or whatever many customers. Those are not necessarily our customers now, but it could be tomorrow or a month later or whatever, whenever that could be. So left-hand side, the all potential customers. Okay, and that is usually in the expert world, a statistical term, we said a population, and right-hand side is the sample size. And then what we know at this point is the mean or the average of these current customers, which is happen to be $2,000. But what we don't know is the left-hand side, the real average, sales values, because we don't know those customers yet. Okay, but if we have this like a confidence interval, I put like 95% because 95% is the one that you use very often, but this could be 99% or 91% or different variations as well. I'm going to go with 95% confidence interval. So when you draw this line, right, and then our expectation is that the true mean, a true average, which we are not going to be able to know because we don't know that whole entire population or entire customer, potential customers. But we expect, if we could know, that value should reside within this range at the 95% chance. Okay, so so what that means, technically, this is a kind of statistics thing. When you have the population, which is like in this case, potential customers, and when you sample is like randomly select in a subset of the whole group. So let's say 10 people, you take the 10 people, randomly choosing them, and then take the average, and then calculate the 95% confidence interval range. And then you repeat this process many, many times, right? I'm talking about very theoretical stuff here. And then it becomes, this is let's say we did 6 samples or something. And that means we have 6 means, like a mean or average of each sample group. And then we draw the 95% confidence interval lines. Okay. Then 95% of these confidence intervals should include the true mean of the population. Okay, so in this case, we have only 6, but you just imagine we have 100. And then 95 of them should include the true mean. Again, we're not gonna be able to know the true average or true mean. So this is really the theoretical things, but this is how we actually think of 95% confidence interval. And then, of course, we have only one data in our hands, right? You have your sales data or your customer data, right? So you have only one data, and then you're not gonna do the sampling kind of stuff. This is just the idea or a theory. But when you get the average calculated, and then you can calculate the confidence interval. And what you actually get is really, that means you're looking at one of these samples. So when you have 100 samples, and then take the average of each group, and then draw the 95% confidence interval, and then 95 of these should include the true mean. 5 of them it doesn't include the true mean or true average. Okay, so that's really the concept of the confidence interval. And then this is a mathematical idea to calculate the confidence interval. So for the 2 things, right? So one, 95% this confidence interval can be calculated for mean, okay, and then also a ratio. So let's start with mean. Mean case, basically you calculate a mean, and also you calculate a standard deviation. And then you put in those 2 things in this calculation. And then right-hand side, you see a root n 1 divided by root n. So the n means sample size. Okay. So what this really is that the n is the most important thing here. The n is a sample size. So for example, when you have 5 customers, you put 5 here. You had 100 customers, you put 100 here. You had 100,000, you put 100,000 there. And then you get that confidence interval. Interval. Okay, so this it says plus minus 1.96. So like a smaller side or like a lower side to the upper side. Okay, and then when you want to calculate the confidence interval for ratio, especially for 95% case, and then the formula is slightly different because for the ratio case, we don't have the standard deviation. Instead, we have a ratio. This ratio meaning, for example, like when you have the customer data and who converted, who didn't convert. So like true or false kind of data. And then like you can calculate the conversion rate. That's the ratio. And then once you calculate that, and then you put that let's say conversion rate or sign up rate, or maybe like a churn rate, whatever the rate that, that kind of numbers, you can put that in this formula. And then again, there's an n is in this formula. The n means the sample size. Okay. So if you have 5, if you have 100,000, you put the number here. Then you get confidence interval calculated. Okay, so this is just a mathematics stuff. Like you don't even have to remember this. Like it's just there. This is sort of like internal thing or a background thing. When you use Exploratory, like it does that automatically for you. Okay, so that's the concept of the confidence interval and when and how to use it. So when you want to use, well, 2 things. Number 1, you want to estimate the range within which the true mean or the true ratio should reside. Okay, so just because you get the average number, just because you get, let's say, the conversion rate, doesn't mean that number is the absolute truth, right? Because the data varies, there's always a variance, and then just random thing happen, like all of a sudden, like one particular customer comes and go kind of stuff. So the number can be very different. So you want to know that what is the range that you can expect the true mean or true ratio should reside in. Next thing is actually more useful and important, which is you want to compare, multiple things, right? Like you want to compare the sales among the countries. You want to compare, conversion rate among the channels, right, where the customer is coming from. Then the difference that you find in the data, let's say like you calculate, conversion rate among, group A, B, C, and then let's say like B is high and A is middle and C is low or something like that. You're basically finding is that, hey, there's a difference here. And then you want to know, is that different? Is just a marginal difference or something that you should spend time on it? And that's a very important question. So those are the time like you want to use confidence interval. How to use it? Well, so again, going back to Japan, US, we are comparing the average of the sales between these 2 groups. And then the confidence interval line is like you saw in the formula that really depends on the sample size. When you have the bigger sample, then the confidence interval becomes shorter. When you have smaller sample meaning that the word sample sometimes confuses us, but it's not really, when you do the data analysis, you're not really doing it, do the sampling at all. You have your data, that's it. But that data can be considered as a sample in the statistics world. Okay, in the statistics world. Okay, so. But this basically sample size is like a data size. Maybe I should say the data size. So when you have the smaller data size, then the confidence interval becomes longer. Okay. So that means the true means, true average can be here as black dots. Okay. So that means, in this case, Japan, US can be very different, right? Or can be here. And in this case, Japan, US is not much difference. It actually can be the same. What these 2 confidence interval lines are showing us is that these lines are overlapping on each other. That means we cannot say there is a significant difference between them, at least statistically, we cannot say, because we don't know. It can be, both of the average can be within this range, like a kind of overlapping zone. Okay. But if we had more data in Japan, let's say like we have more customers in Japan for some reason, then the confidence interval can become shorter, right? And at this point, again, the true means can be here. Oops, sorry, there's at the x-axis is somehow the Japanese are there, but left-hand side is Japan or right-hand side is United States. And then true mean can be here. And even the extreme case, like the highest on the US side and lowest on the Japan side, but they are still difference. There's still difference, right? We can say Japan is higher than US in this case. So the important thing here is that confidence interval lines are not overlapping. Okay, so therefore we can say there is a significant difference between them. Okay, so that's how you use it. That one was basically average we are looking at, or average or mean, but ratio case is the same thing. You're comparing the conversion rates or churn rates, the same thing. It's really what it matters is the confidence interval lines are overlapping or not overlapping. Okay, so let's start looking at one by one by using the charts in Exploratory. Okay, so the error bar, like again, so there are two sort of like things that like you want to look to use the confidence interval when we compare. One is mean or average, and then the other is a ratio or rate. Okay, so let's start with mean. So we have this sales data. Okay, so each row represents each customers, and then each customer's sort of attributes, like what their job is, what their marital status is, but also there is information about store, which store these customers are doing the shopping for at, and then there's monthly spending, how much money they spend monthly basis. Okay, and then we want to see like which store is has higher average sales or not, right? Okay, let's start looking at here. Where's that? There you go. Here is the data. Okay, and then here is that table. So each row is each customer, and then I want to see like which store has higher monthly spending in average or not. So when I go to the chart, and then the first thing usually we would do is, okay, store the x-axis, y-axis. I'm going to put like monthly spending, not the total. We are talking about average. So this is like average spending. I'm going to sort this. Here you go. And then we can see like, okay, Napa, Palo Alto, they're two like sort of like super highest. And then I got next group around these three stores, and then like another stores on the right-hand side. Okay, so that's good. And what we want to know though, for example, I mean, these two like very different. So like that's one thing we know. But for example, Napa and Palo Alto, is this different? I mean, like, can we say that Napa is higher than Palo Alto, or this difference is probably a marginal difference? We should consider these as just the same. Or for example, here, Sonoma and San Francisco, there's a difference. Is this difference significant or marginal? Okay, so that's the kind of thing we can answer. And then just to show you that, this whole thing is really depending on the data size, right? So how many people actually in Sonoma store, how many people shopped at the Sonoma store or San Francisco or Palo Alto? Like I'm going to use this scatter with aggregation chart. And then the thing I like about this chart is that not only showing the average, this part is the same as in a bar chart, except there's no bar, right? But also I can use a size, and then here I can set like a number of rows. Now each circle is representing the number of the customers. So the bigger the size, the bigger the more customers. So it looks like San Francisco has a lot, but compared to here, Sonoma has only like 52 customers. San Francisco have 325 customers. So as we can imagine, like probably if we put a confidence interval, San Francisco is shorter because more customers. Sonoma is longer because less customers, right? And then with that, then is there still difference? And the same thing with the Palo Alto Napa as well. Okay, so that's where we can use error bar, this one. Okay, so I'm going to switch to the error bar. And then right now, this is like a black line at the top of the bar chart is the confidence interval. What's the confidence interval? It's like a 95% confidence interval is the default. Okay. And then I want to focus on the confidence interval itself rather than the average numbers so that I can compare the confidence interval to see confidence intervals are overlapping each other or not. So I'm going to switch the marker to the circle. And then the circle, then the bar disappear. But still, what bar was showing, which was the average, is shown as this circle. Okay. And when I see here, looks like Napa and Sonoma, they're almost like, they're not really overlapping this here. So, okay, even though these two are very close, but we can say with this data, there is a significant difference between those two. Okay, the Napa is higher than Palo Alto. How about Sonoma and San Francisco? Okay, so this one, again, there's no overlapping. So it seems like that this difference is significant. Okay, so this one, like we are looking at the average, but there's another thing in this data, which is here, the churn. So some customer churned, or maybe they disappear from the store or something. So we want to know, like, what type of the customers tend to cancel or churn, which customer not cancel. Okay, and the same thing, like there are a bunch of things, but like I'm going to use a store again and see to compare. And so I'm going to create a new chart and then error bar, and then doing the same thing on the x-axis store. But this time, though, like I'm going to not the calculation type of the mean. I want to focus on the ratio because this data here, the churn is not the numeric. This is a true or false. So like I want to see like what's the percent of the true, percent of the customers who said whose data is true. Okay, so go back to chart, and then I'm going to assign y-axis to this oops, I'm going to select the ratio. Otherwise, I can't even select the churn column. So I'm going to click on the ratio, and then y-axis to be this churn here. And now this churn, this thing is supposed to be showing the rate of the true or percent of the true. However, here the ratio by is important. This is like all. So this means all the true people in Oakland against all the true people in this data set. What I want to do is for each x-axis, what this really means is each x-axis, so this is the x-axis, Marine or Napa. In Marine, and what is the percent of true people? Here's a number of true. What is the ratio of number of true? For example, in Napa, and what is the ratio of number of true, meaning number of the churn people? Okay, so that's this like a ratio by thing. And then like I want to do the sorting. Then again, I want to focus on the confidence interval. And in this way, like I can see, okay, so like Marine is high, but Marine and the Sonoma and then San Mateo, these three, I don't think there's much significant difference. So these three tend to be higher churn rate. So that's one good information. But among them, there's not much difference. But when you compare with Oakland and San Francisco, then we can say Marine has higher, not only higher, but also there's a significant difference between them. Okay, so that's the ratio. And it shows detailed information that you can see inside in this bubble or the box. And it says number of the churn, but also number of the totals, like 83 at the bottom. That's the number of the customers in Marine. Okay. And then the second from the top is a ratio itself, 45%. And then the range indicates the confidence interval. Okay. Okay, so let's go to the next one. Here we go. So when you have the data like this is like a website conversion data. Okay, so each customer comes to our website, each user or whatever, and then we track like that person converted or not. Just imagine like they put like email to sign up, or they put a credit card to convert, whatever could be conversion status, true or false. Okay, with this kind of data, as we saw, you can assign this conversion column to y-axis, and then you can get this error bar. So that's pretty, I wouldn't say simple, but something that we already know. Okay, and then what's happening inside of the error chart is the error bar chart internally aggregate the left-hand side data into country level, because we assign country to the x-axis. And then it calculates the number of the converted and number of the total per country. And then using that converted and total column, or number of the true column and the sample size column, it calculates the ratio. Okay, this sample size again is a data size. And once you get this ratio, and also we still have this sample size or data size, with these two, we can calculate the confidence interval. And that's what we were seeing. Okay, so those calculations was done automatically behind the scene. And here's the problem. Sometimes you get the data like this, which is already summarized. This happens a lot, especially, for example, for my personal experience, when I use Google Analytics. And the Google Analytics always return the aggregated data, not like a detailed user level data. So in that case, we know how many people converted for Japan, how many people converted for US, and how many people were in Japan, how many people are in US. We know those information, but it's already aggregated. Okay, and then this kind of aggregated data we can't use the same error bar. However, there's another error bar type called error bar bracket summarized data. With this one, we can solve this problem. So let's take a look at it. So when you have the aggregated data like left-hand side, then you can assign converted column to the y-axis like we did before. But also there's another column you can assign, which is a total, which is basically the data size or sample size. Okay, and then assigned to the total number section, then you get basically the same chart. Okay. So what this error bar bracket summarized data chart is doing is it calculates the ratio and the confidence interval based on the number of true column, in this case converted, and the sample size column, in this case a total. So it's only that ratio confidence interval part calculation. It doesn't do the summarization or aggregation like the other error bar type, because the data is already been summarized. Okay. All right, so let's take a look at this one too. I happen to have the data has already been summarized. So here, there you go. So this kind of data. Okay, so now like a date and a country user conversion. And then I see like user level, country level already aggregated, even though the date is different, but is aggregated at the country level. So what I want to do is I can go to the chart, and then instead of selecting the regular error bar, I'm going to select error bar with summarized data. And then again, change to the ratio. And the x-axis is country, and the y-axis is number of converted, so like a conversion. And the total number is number of the total users. So in this case, user. And I get this error bar chart. And then I'm going to select a circle. And then basically I get a similar chart here. So left-hand side, Japan, and the confidence, the ratio is 5.35%. And the confidence interval is 0.27%, upper or higher, go up or down, both sides. Okay. Okay, so this is where you want to use a summarized version of the error bar. Okay, so next one, I like to go to switch gear a little bit. So we have been using this kind of chart view. Okay, but let's go back to the store sales data. There's another and easier way to make this error bar, which is using the summary view. And when you go to the correlate mode, okay, and what we did was we wanted to know the average sales by the store, right? You can actually do it inside a correlate mode and then select that, let's say like monthly spending. Then what it does is it basically create an error bar chart for every single columns. And then as long as it's a character column, character data type column, you see that error bar already here. So you don't even have to create a chart. It's already been generated. And you can see where is the difference. Okay, so here is a significant difference. Here is not much, or gender. In this case, there's not much difference. I mean, there's a difference, but it's not like significant difference. So not only one column or one attribute, you can see all the attributes. And if the data type is not character, instead of numeric, then you still see the confidence interval, but in this case, a line chart. And then with this confidence interval, kind of like a band or a zone. Okay. And in this case, for example, line chart, when you see the confidence interval is so big, and it's almost, you can draw the lines kind of like a horizontally, like a flat line. That means it doesn't mean that it goes up or goes down. So probably in this case, beer tasting class, number of the times attended, customer attended. It doesn't really matter because it can be like a flat line. That means the more class attend, but sales can go up or go down, or it's not going to go up and down. So there's not much relationship between the beer tasting class and the monthly spending. Okay. So it's a similar idea. There's not much difference, or even the character, the categorical stuff is overlapping. That means there's not much difference. Okay. And another bonus is when you move the mouse cursor on top of the column, then you see this chart icon, and you can click on it to get that chart. So then in this case, you don't even have to kind of like do nitty-gritty thing to create this chart. You already have that chart. And not only the numerical, you can actually change that, in this case, monthly spending. Instead, we can select the churn. Now we are looking at the churn rate by the, for example, region or store, gender, and so on. And you can quickly see where the significant difference. For example, like marital status seems like here, it seems like there is a significant difference. Okay. Okay, so that's a summary view. And then next topic is line chart. Okay, so this is going to be the last topic. So this happens a lot with when you do something like A/B test kind of stuff. Basically, like you have 2 pages you created, and you want to test. You guys, you had an argument like, hey, like button should be red, button should be blue. Well, the goal is to increase the possibility of users sign up, right? So which one draw more attention, which one can help increasing the conversion rate, sign up rate. Okay. And then you collect the data. So you basically tested it. You created 2 versions, and then you observe like when the new users come in, and then day by day. Okay. So like each row is each day, but also each page. And then like unique page view, meaning how many page view you had. And then sign up count is like how many people actually sign up. And this actually data originally came from Google Analytics. And then I manipulated a little bit to make it more like a demo ready. But this is the kind of data that you get from Google Analytics. Okay. And then the testing period, when you look at the date under the summary view, this is from this 2020 June 1st to July 21st. So it's about, I don't know, like 1.5 months or so. Okay. And then when you can actually use the error bar, and this again, the data is summarized, right? Like we don't have the user level, each user sign up or not, that kind of stuff. It's actually page A, page B level, like being already aggregated. So you can use a summarized data version of error bar, and then visualize the confidence interval. And then you see like page A, page B, and what's both of them showing is the conversion rate. Okay, with the confidence interval, because they're not overlapping, so there is a significant difference between them. Okay, so that's good. But when you think about it though, like now that we know, like after 1 month and then 20 days, like we know like page A is better. But did we really need to wait for this long? Maybe way before down the line, let's say like maybe like after 2 or 3 weeks, we could have known that page A was better than the page B. Okay, so usually when you do this kind of test, you do hypothesis test, and then you calculate sample size first, and then you wait until you have enough data. So that's more like a correct way of doing it. But when you use this confidence interval, you can do similar thing without, calculate the sample size, beforehand. If you ask me which one you recommend, yeah, of course, like not of course, but it's better to know ahead. So like you want to calculate what is the sample size you need at the, beforehand. And there's a way to do it, even in exploratory, when you go to chi-square test, and then there's a way to calculate the sample size and stuff. But in this case, like I want to use confidence interval to give you some idea, like when is the enough time to have enough data to tell you that there's a significant difference or not. Okay, so basically, if we can know something like that, after a couple of weeks later, then you can stop the testing there and you can move on. Maybe like implementing, or deploying that page A to all the pages. Like all the instances. And then you can start, increase, you can start having increased signups, right? So that's what we want to do. So that's where the confidence interval comes. And then let's see, what I want to do here is a little bit of data wrangling involved. Okay, so I have this data. Oops, oh, I clicked on the wrong button. Somehow I closed the project. I'm gonna open it. And here we go. So here's the A/B test data. Okay. And then the data looks like this. Okay. So this is a summarized data. And then I can use that error bar. But what I want to do is to calculate the ratio, but also confidence interval for each period. So like let's say like June 1, June 2nd, and that kind of stuff. So the way to do it is you can actually do the data wrangling. You can actually use this error bar here, summarize data, and then ratio, and the x-axis to be, let's say, date, and I want to do by the date, and then y-axis to be sign up count, and total number to be unique page view, and then let's say something like this, and then like I want to see like a landing page 1B, and this one is so confusing. Like I'm not sure like what are we looking at here, because this is like a time series data. So you want to use a line chart and see like a trend, right? So that's what I want to do. Like unfortunately, you can't change this one to the line chart. So for doing it, but there's a way to do it. So like I want to do it. So to use a line chart, you want to do the data ready. Basically, like you got to do the calculation first. Then you can use a line chart by assigning some calculated columns. So how are we going to do it? So first, each day, this is like a June. Wait a second. Okay, so this is like a A and B. So like I want to do the calculation for A and B separately. So I'm going to use a group by here. And so what I did was basically created a page A and page B to be like a different section. Okay, so like A group and a B group. Okay, so it's kind of a different partition. And within, I can do calculation for unique page view, sign up count. Yeah, okay. And then actually, sorry, I'm going all over right now. I just realized that if you do it, you can get this kind of chart, okay? But when you think about it though, one thing we gotta be careful is if all the conditions are the same, let's say like the randomly, like the users are randomly separated and coming to the page A, page B, down the line, like then we should consider the number of the people that should be accumulated, right? So it's not like each day you calculate the ratio and the confidence interval. Instead of doing that, like you want to do the accumulating number of users as the day goes by. What that means is basically what we are looking at is something like this. Okay. So June 1st to June 6th, only 5 days. And if we calculate the ratio for each day, and then calculate the confidence interval, you get something like this. Okay, so the first day was a 20% conversion rate, second day, the 40% conversion rate, and so on. But in the real sense, like by the second day, instead of the second day, you have 5 people. Instead, like by the second day, you should have 10 people. By the third day, you already have 15 people being accumulated. Fourth day and fifth day, you have more people, right? Like, so you want to do the accumulate, basically the data size becoming bigger. So that means the confidence interval depends on that data size. Therefore, confidence interval range becomes shorter as the day goes by. And that's what you want to do when you do something like A/B testing, or it doesn't have to be A/B testing, but when you do kind of a time series data, okay? Because more data, more customers you have, then you can be more sure that range of the to ratio should reside in, right? Okay, so that's what we wanted to do. So if we can do that, then like we can draw the line like this, and then we can visualize the confidence interval. If we can do something like this, then this is around the time those 2 lines, those 2 lines are separated, but also confidence interval doesn't overlap around this time. Okay, then we can stop the testing, right? Okay, and what we saw with the original error bar chart was basically at the end, like all data for page A, page B, and we calculate the ratio. That was the error bar was doing. What we want to do, we want to visualize by the timeline. Okay, so to do, that's what I wanted to do. So here, first, I want to calculate the cumulative number of the unique page view and the sign-up count as the day goes by. And it seems like the data is already been sorted. If not sorted, I should have done it's like an orange sort, but if data is sorted, I'm going to go with this one. And then I'm going to count like there's something like a window calculation. Under the window calculation, there's a cumulative. And I want to do the cumulative sum. Okay. To calculate the unique page view. I'm going to call it unique page view underscore CumSum as default. Okay. And as you see here, the number is being added like as it goes, so like accumulated. Okay. And the reason I did this group by is because I don't want this number to keep going up. But when you go from page A to page B, I want that number to be reset, right? Because I want to know the cumulative number for the page B, cumulative numbers for the page A. Okay. And I want to do the same thing. We can do the same thing for sign up count, create window calculation, cumulative sum total, and then click run. So we have these 2 columns. Once we have these 2 columns, then we can calculate the ratio of each day or for each page. So create calculation, and then unique page view. And then, so I want to calculate sign up count CumSum, and then divided by unique page view CumSum. So this is the ratio by the day. Okay, so first day is 9%, second day 9%, the third day is this is like a 10%, 0.1 is a 10%, and so on. Okay, so at this point now we know the ratio, so like we can use a line chart to show this how the ratio is moving. But I want to calculate the confidence interval so that we can visualize that as well. So how we do that? So from the ratio or any column, but I'm going to use a ratio, create a calculation. And it turned out there is a, I'm going to just remove this, confidence ratio. Okay, so it's kind of confusing. There's a two type of the things. So the first and the second. The second, conf int ratio is the one like you want to use because it does take care of this is you can do with the aggregated data like this. Okay, so what that means, the conf ratio conf int ratio, and then what you want to do is basically first is a ratio, and the second is basically the one to the sample size or the data size. So in this case, unique page view sum. Okay, so this ratio, right? And then we want to calculate the confidence interval, which depends on the data size. This is a data size. So that I give it these two information. This is very similar to what we did with the error bar chart and the summarized data bar, right? So, and then I'm going to just call it like a confidence interval, like just say the CI, and click run button. And then now we have created this like a confidence interval for each row all the way down. Okay, once we have this though, we want to calculate the lower bound and the upper bounds. Okay, so to do that's pretty simple, like you minus or plus with this ratio. What that means, so here's a ratio, create calculation, and minus CI. So that's the lower range, and lower end of the range. Okay, so I'm going to call it lower, maybe like CI lower. Okay. And then the same thing, the upper range, which is create calculation and plus CI, and then confidence interval upper or something. Okay, so now we have the lower range and lower end and upper end, and these are all the information we need. Okay, so when I go to the chart, and then I'm going to select the line chart. And the x-axis, I'm going to assign the date, and then aggregation level is to be day. The scale is day, and the y-axis at this, I want to show the ratio, and then I divide by the color. In this case, the page landing page. So this is a page A, page B. Like we are seeing the ratio. All right, and then in this case, the ratio is like this accumulated based on accumulated unique page views and the accumulated signups. Okay, and then we want to show the confidence interval here. How we do it? So here from the menu, you can assign. And this one is currently it says sum because we know for sure at the day level we know only one data. But just in case, I'm going to just make a mean because it happened to be two information in the same day. But it doesn't really matter in this case. And then from the menu, and then there's a range bracket, conf interval, or etc. You can actually assign columns to set the range. So I'm going to select the range, and under the range type, there is a column. So this is kind of confusing because if you can select the confidence interval, but this confidence interval is basically use the number of the data on that particular day. Again, if the data is not aggregated data, so let's say like each day you have like 100, customers or something, and then like you want to calculate, the average sales or average, conversion rate or something like that, then chart can do the calculation for you. But in this case, we already calculated because this is aggregated data. We are just passing to the chart. Therefore, you want to select this column. And then like upper limit, I'm going to select upper, lower limit, and then apply bottom. And that's basically what we are visualizing here. So this one is under the table. We have this like a CI lower, CI upper. That is basically being visualized. Then again, we can say probably around here, June 14th or maybe later, like almost like these two confidence intervals are not overlapping. So this is a kind of a sign that probably these are significant difference. After this point, the line is not really crossing. And then if the users were selected randomly, and then it's very hard to imagine like after the maybe like a June 28th or something, the line going back to kind of going to different direction or something like that. So at this point, maybe just a matter of time, like hey, maybe like we can just stop the testing here instead of like keep testing all the way down. Okay, but the important thing here is that even the line chart, you can show this confidence interval, and then you can do that as well. Okay, that's pretty much it. And then so I want to before closing, I want to just kind of conclude. So again, we talked about confidence interval. And the important thing is when you want to use it. So one is want to estimate the range within which the true mean or true ratio should reside. And then the second point is really important when you want to compare among groups, such as country or pages or channels, whatever, in a given data, the data you have. But you want to see that difference is significant or something that you should pay attention. Okay. And then how to use it, like make sure those confidence interval lines are not overlapping. If it's not overlapping, then you can say there's a significant difference. It's overlapping, then those differences are marginal difference or just random difference. Okay, and then one way to do it is creating a error bar or error summarized bar chart, summarized data. But the easier one is to use a summary view, and then you assign numerical or logical column. And then click the chart button. That's the easiest way to create. But exception is that sometimes your data might have already aggregated. Then you can start with, then in that case, you can start with the summarized data by using error bar bracket summarized data. And also the line chart, you can show the confidence interval. If your data is, let's say, more like non-aggregated data, let the chart aggregate. In that case, you can use the confidence interval property to draw that confidence interval range. But especially something like A/B testing, as the day goes by, that means the data should be accumulated, or number of the customers or number of users should be accumulated. In that case, you want to do the data wrangling to calculate the cumulative numbers and then calculate the ratio. Then use the calc_conf_int ratio. If this case is a rate or ratio information. If you want to do average, then calc_conf_int_mean function. Either way, then you can use it to calculate the confidence interval values. Once you calculate those values, then you can visualize by assigning those columns. Okay, that's it for today. We have, like other seminar coming up, and you can check our future schedule by going to our homepage under the Learn, go to the online seminar, and also you can see all the past seminars recording as well.